Thank you for coming to this webinar, and good morning, good evening, or good afternoon, wherever you may be in the world. Again, my name is Jason Mimic. I'm a senior consulting engineer with MongoDB. And so what that means is I travel around and visit with all different kinds of customers with MongoDB, and from very small startups to large corporations, and help them follow best practices, help them design new applications, help them set up servers, set up things like Ops Manager, all different kinds of things. Every week is something new and interesting. But today I'm here to talk about the aggregation framework with all of you. And before we get started, I wanted to just take a few seconds to do a survey here so I can get an idea of kind of the different members we have in our audience. So if you could click on this, and getting results in like crazy. We've got about half the people. So it looks like this is very heavily focused developer audience, which is wonderful. Great. So let's get started with the presentation. Thank you for responding. All right. So before I get into things, I wanted to just lay some basic ground rules here. So this is definitely a 101 level or a beginner's talk. I'm going to assume that you know some basic things about MongoDB. You can get into the shell. You can do some queries. You understand documents and schema lists and all those kinds of concepts, but are basically new to the aggregation framework. So if you have some experience with the framework, probably some of this talk is going to be a little bit basic for you. We do get into some advanced things, but I do want to set that as a level set. The other thing I wanted to point out is I have quite a bit of content, and we only have about an hour, and I do want to have time for questions. So we may not get through all the content. With that said, this deck will be available as well as a recording of things after the webinar. All right. So in terms of agenda, we're going to talk about what it means to do analytics with MongoDB. We're going to look at the aggregation framework, what it is, what the syntax of it is, and what some of the various different operators on that. Then we're going to use some actual U.S. Census data to look at some real-world examples of using the aggregation framework and getting some more information out of some raw data. Look at some different options on the aggregation framework. And then towards the end, I wanted to throw in a topic on MongoDB 3.2 because there's quite a few new features in the aggregation framework that people are really excited about. There's something called $lookup, which is one of these new features that lets you do basically simple joins, if you want to call them that. And so hopefully we'll have time to get into that. And if we're running short on time, I may skip some things to at least bring that up because I hear a lot of interest from customers on this. So I do want to at least touch on it during our hour here today. All right. So what does it mean to do analytics in MongoDB? As you all know, MongoDB is a document-oriented database, and we store our documents in JSON notation as these little JavaScript objects. And the basic capabilities of a database are, the ability to create data, go query that data to read it, to update it, and then get rid of data that no longer matters. But in all real-life applications, you actually need to do more complicated things with your data. You're looking to do things like count records that have a similar value, filter things, look for averages, group things, all different kinds of things to build your applications. I see a little chat about 3.2 changed from BSON to JSON? No. So the on-disk format of data in MongoDB is BSON. I'm talking about the logical format that your programs use and the way you think about it. So the aggregation framework is really a way for you to do these types of analytics. And I also want to point out that the level of analytics that I'm talking about here are kind of like, working at the low raw data level. We're not talking about higher level, BI tools with very rich visualizations and fancy user interfaces. The aggregation framework really provides you the low level, operators and functions to actually massage the data out, massage your analytics out of your raw data so that you can then feed them to those visualization tools. Okay, a word on some of the sample data that we're going to be using to kind of walk through the aggregation framework here. We grabbed some data from the U.S. Census Bureau that contains information from, the last 30 years, 1990, 2000, 2010, 25 years, 26 years now, of censuses. And that's broken down by different areas in the United States. So, for example, the data is broken down into regions and then states and things like that, and we'll look at some of the documents. We're going to try to drive toward asking a fairly complicated question out of this data set. We'd like to find which division in the United States has the fastest growing population density, where this density is basically the area of a division. So if you take all the states in a particular division and add up their areas, and then you divide that by the number of people, so we can look at the differences in population density between these different time points, 1990, 2000 to 2010, and then try to determine which one is growing at the fastest rate. So when we get to the answer to this, you're gonna see it's a fairly complicated aggregation, but we're going to start off with some basic things and look at how you can solve that. Now, in the SQL world, you'd probably write some SQL that starts off with something like select stuff, group by something, and having some other different clauses. But of course, in MongoDB, we don't have anything like SQL, right? Because MongoDB is a NoSQL database. So how do you solve questions like this and simpler questions using MongoDB? Well, that's where the aggregation framework comes into play. So this little cartoon actually just does a good job at a sort of a meta level of describing the aggregation framework, because in the end it is just a framework. So it is a set of functions, operators, and features within MongoDB that you can leverage to run complicated queries that do things like group and count and things like that. But it doesn't really do anything unless you program it to do it. So we're going to start with looking at the core concept of the design of the aggregation framework. And that is actually really simple. There's really just one core concept that you want to keep in your head as you're building your aggregations, and that is of a pipeline. So if you're familiar with the Unix and Linux worlds of the pipe operator, so this operator is used to redirect the output of one command to the input of another command. So you're all somewhat experienced MongoDB users, and so I'm sure you many times logged onto one of your production servers or test servers, and were wondering if Mongo was running. And so you probably typed some kind of a command similar to this to list all the processes and then find the ones that contain the string MongoD. So in this case, the output of the PS command becomes the input of the grep command. This is the fundamental concept of the aggregation pipeline, and really the one thing that you need to keep in your head. All right, so let's dig a little deeper into that. And what do we mean, how do we apply that concept of a pipeline to an aggregation? So within the aggregation framework, when you're running an aggregation, you're going to send your data through a series of really document transformations or different kinds of operations. And each of these transformations occurs in one stage, such as something like a match or a project or a group or a sort. We're going to go into the details of what these things are, but you can probably guess or have a rough idea from the name of them. So the output of a dollar match becomes the input to a dollar project, the output of the project, the input to the dollar group, and so on. Keeping this in mind, it's very easy to build complicated aggregations by just concentrating on each stage and looking at the input and output of each stage, and then stringing these together to do very complicated things. And we'll look at some techniques that you can use on the development side as we get into more examples here. One thing to note, each of the operators, and that's what this rich library of functions, we can call them functions or operators. They do all kinds of things like group, summarize, filter things. They'll all start with a dollar sign. This is a syntactic note. So very similar to the standard MongoDB query language, where you use things like $EQ and $LT. That syntax is just built upon with the aggregation pipeline. So if you're familiar with that, the syntax over here with the aggregation framework should feel very natural. So let's take a look at an example of an aggregation. So here I have a collection called orders. In order to do an aggregation, I call the aggregate method. This particular aggregation consists of two stages. One is a match and one is a group. We'll get into the details of this syntax a little bit later, but as this example shows, what you really need to focus on is the input and then the output of each stage. So in this case, the dollar match takes as input the entire orders collection. So match is going to iterate through the entire orders collection, looking for ones where the status is equal to the string capital A. And so the output of dollar match is just precisely going to be those documents where status is A. This is exactly like if you did db.orders find status : quote A. Very similar, exactly the same thing. But then the group is going to do things to do something a little bit more complicated. It's going to group up on something called the customer ID. So take like documents and then actually sum up the different amount values. And we'll look at some more examples of this as we go through. So the syntax for an aggregation within the Mongo shell is composed of essentially 5 different parts. So you always have, your DB variable, which points to the current database. You have the name of the collection. You have the aggregate method. And then the one thing that is probably a little bit new that you have to get used to when you're writing these is that the input to the aggregate method is actually an array. So if you notice the square bracket here for the beginning of the array and the square bracket at the end for the end of the array. Now what's in the array is a set of, again, JSON objects, but each of these objects is one pipeline operator. So that is the basic syntax. Now, not everybody lives completely in the shell. I understand that, so I thought I would also just show you a quick example of what an aggregate might look like from the Java perspective. If you're coming from the .NET world, C# is very, very similar to this. The names of the different classes in the different drivers is slightly different, but the concepts are the same. So in the bottom of this slide, you can see an aggregation over a collection called hospital that's going to group on patient ID and then do some matching. And up here, you can see the same $group, $match, $sort within the Java syntax. I wanted to show this to you so you can just see what the translation is. For the rest of the talk, we'll be sticking with the shell since it's sort of a lowest common denominator that regardless of which driver that you're using. So at a high level, there's a number of, I'll say, popular pipeline operators, things that are used quite often like match, project, group to summarize, unwind, which deals with arrays, sorting, and redact is actually a pretty complicated one that lets you restrict data coming out of a particular stage of the pipeline. We'll also look at GeoNear, which allows you to use GeoJSON data to do geographical type queries within your aggregations. And there's also a few operators that let you define variables. For the beginning of this, we'll concentrate a lot on the first four here, maybe five, because $group and $unwind are probably the more complicated ones to wrap your head around when you're new to the aggregation framework. So there's a couple of things of that I really want to emphasize. But now, as of MongoDB 3.2, and this is almost a full list. I mean, there's 80, almost 90 different operators available. So, you know, as MongoDB evolves and we try to tackle more complicated use cases, you'll probably see this set even expanding more to take on new different kinds of features and operators that people need to solve their analytical problems. Okay, so let's take a look at our sample census data and look at how some of these aggregations work. Okay, so we have a few different collections within this sample data set. We have a collection called CData that has a document for each state. Again, and as I mentioned, we have another collection that contains, well, actually in the CData collection there is information for the different census, and that's actually contained within an array. So I'm going to try to share my desktop here. And quickly just give you an idea of what one of these documents looks like. So here, for example, is one of the CData documents. This happens to be for AL, which is Alabama. So you can see within the data array here, there's an entry for each of the years with population, and those are probably household numbers or something like that. And one of the things you really want to do when you start doing an aggregation is, you know, you're going to be given some sort of problem, you know, written in English or whatever your language may be. You're trying to solve some problem. And so you need to translate that problem into the different operators that you need to use over your data. And to even start to do that, you really have to go look at your documents. You have to look and see what's there in order to figure that out. It's not something that's just completely obvious. Every different collection is different. You may even have collections where the documents don't all look the same. So you have to get to know your data. You have to look at it. And if you notice here, we have 52 documents in this collection. So we must have some for other things that aren't really states, like I believe District of Columbia and maybe Puerto Rico is in there. So here for an example, so yeah, we can see we do have District of Columbia and a few other things. So just wanted to point that out, that that's an important thing to do. Okay, so now we should be back to the slides. Okay. So this is what I was just talking about. So take a look at your data, look at some documents, see what's there. All right, so there's also a collection called regions in this data set, which basically organizes each state into one of the different regions. So let's say we were interested, and here's an example document from the regions collection, state, and then division. And so how can we find out how many states are in each region? Region here being Northeast. So in this case, we need to use the $group operator, because we want to take all these documents in the region collection and group up the ones that have the same region. That would be just this region key. And then we want to count up how many of those have that particular region. So let's look at the answer to this. So up at the top here is kind of like the hello world of the aggregation framework. It's a $group operator. And I want to talk through the syntax here because it's very particular. And if you don't understand this, you're going to have a lot of trouble with using $group. So the input to this stage will be the entire collection. And syntactically, $group has one kind of thing you need to remember, and that is the argument or the value of a $group. So this is one document here, has a key $group, so that's the name of the aggregation operator, and the value to that is a document, which you can think of that as what you're specifying in this document is the shape of the documents that you want to come out of this stage of the pipeline. And by shape of the document, I'm saying you're giving a template for what the structure of those documents should be. You're going to define a set of keys and what those values should be, and there's some special syntax in how you specify that in this template mode. In particular, there's a couple things. Number one, you'll see here an _ID key. That is required to the template document that you give to $group. The _ID key for this document will point to the key in the incoming set of documents that you want to group on. And you use the second part of the syntax with $group, and in fact all operators in the aggregation pipeline, is that you use a $sign to refer to keys in the incoming set of documents. So what this says is, in the regions collection, for each document coming into this stage, I want to take the value of the region key and group on that. So the _ID for $group always needs to be there. And then this should point to either a key, or the _ID can actually be a document with multiple keys that you want to group on. So $sign refers to the key on the incoming set of documents. The second key that we have in our set of output documents, we're going to call count. And you can see down below here that this is the output of running this aggregation. So each of the output documents has an underscore ID and it has a count. Now, the value for count, we're going to actually use this accumulator operator called $sum, and the value for $sum is 1. So what this means is every time as the input collection is getting fed into the $group stage, every time that you see a new document, it'll add 1 to the count variable, and you can see the output there. Okay, I see we have some questions. I'm going to flip over there and check these out real quick. There's a question about the order of the operators in the aggregation pipeline. Yes, that definitely does matter. I believe I may have seen another question about, do you always have to match before you group? Well, that depends. You might do matching later in a complicated aggregation. You may match a group and then match again. That all depends. But I guess the general kind of guideline there, if there is one, because everything is very specific to your own data, is yes, you would want to if you can filter your data and make the set of data that you're needing to feed into another stage of the pipeline smaller, that's always better, right? Because then it's less work down the line. So in general, you do want to filter before you do other things, but that doesn't necessarily hold for all possible scenarios. There's a question about what are the right tools to tune your aggregation pipeline, and we'll look at that a little bit as we work through this. In general, if you're wondering about that, if you're familiar with using explain on queries, there's an option you can pass to the aggregate method that will output essentially the same kind of information as an explain, and it'll show you what different stages if they're using indexes and things like that. So tuning your aggregation is, in general, is basically the same as tuning your queries, right? You want to have the right indexes, but then you do also want to think about the ordering of things. And I'll look at one other question here, and we'll move on. Okay, so this is a good question. Justin here asks, when you get to the $group operator, how do you get a unique ID as you would a document that has its own underscore ID field that MongoDB puts in? Okay, so using underscore ID for $group, while it's called the same thing, quote underscore ID, it is different than the underscore ID in a regular collection. Underscore ID in a regular collection is essentially a primary key. It needs to be unique across the collection. Using it in the $group context, we do not have that restriction. And in fact, we couldn't, right? Because the underscore ID is trying to group up similar things. So you would expect the input documents to $group to have multiple documents that have, for example, the same region, because what we're interested in doing is grouping them up. The use of underscore ID with $group and then underscore ID as like an object ID or the unique key within a collection is really just kind of a syntactical thing to help you remember, like it's the important thing that you're going to group on, and underscore ID is an important thing within your documents. That's really the only connection there. Okay, so I'm going to pause on the questions and get back to the content, and I'll come back in after a few slides and check the questions again. Okay, so this is the basic thing with $group. You always have to remember the underscore ID, and then you're going to have to get used to this syntax using the $sign to refer to keys or fields in the incoming document. Those are the two main things to remember. One other thing, if you look down on the bottom here, I wanted to point out is, so right now we're looking at simple aggregations. This only has one stage. In real life, you're going to have very complicated aggregations, which get big. And by big, I mean they have lots of stages and they're complicated and things like that. This, unfortunately, is just like in the SQL world, where not everything is, select star from person or anything, right? In the real world, you have very complicated SQL that goes to like 500 or 1,000 lines. And unfortunately, within the aggregation framework of the MongoDB, if you're trying to do something complicated, you may have complicated aggregations too. We don't have a magic tool for that yet, but I'm sure we're working on it. So one thing you can do, at least in the shell, is you can actually store the different stages in your aggregation in variables. So here I've just taken the same thing as up here, and I've just said var group equals my whole $group document, and then I've just passed that in as a variable into my aggregate. Now, in a simple case like this with just one stage, it's probably doesn't make a lot of sense, but if you have multiple stages and you're trying to match up your braces and things like that, using this trick of putting things into variables can help out a lot. Okay, so $group. Spoke about underscore ID. There's also a bunch of other operators you can use in your groupings. You can look for maxes, mins, averages. You can use add to set to add things to an output document that is an array. And in particular, add to set will only add things if it's not in there already. So here a set meaning, an array where each item only occurs once. $push is familiar to just push a value under the array. So in that case, you could have multiple values, multiple instances of the same value within an array. First and last, if you know something about the ordering of your data in an array. And then, by default, all this processing does happen in memory, although there's ways around that. So actually, back to the question about underscore ID being unique, we can extend this and the fact that using it when you're doing a $group, you do not need to do that. We can take that a little bit farther and try to see if we can use $group to find the total area of the United States. And here's an example of doing that. And this is even this may look really odd to you, but here I'm saying I'm going to go over the C data collection now. I'm going to do a $group where my underscore ID is null. That means it's going to match every possible document and only output one document out of this aggregation step. And what I'm going to do is just for each of the input documents, I'm going to build a key called total area that's going to sum up the area of each state within that collection, and then another key that'll average up those values, and you can see the output there. So in this case, I'm collapsing an entire collection of 52 documents down into one document that adds up the area and then also calculates the average. Here's another one extending that to the region value. Here I'll group $group on region. I'll calculate a total area this is the same as before. So that'll just be the sum of the areas in that region. What is the average area? How many states are in that region? And then build an array of all the states in that region. And you can see down below here what the output of that is. And in particular here, there's two documents. You can see num states 2, District of Columbia and Puerto Rico. they have ID null, which that means they didn't have a region in specified in the documents for DC and Puerto Rico, but Northeast, Midwest, South Dakota, I'm sorry, Midwest, West, and so forth, those did. So you can use $group to build up these. You can collapse things down to a single document. You can group them by other attributes within your data. And we're kind of running slow on time. I'm going to skip through a little bit here and talk about unwind. This is probably, as I said, the second one that is a little bit more tricky to wrap your head around. So unwind is used to flatten arrays. And let's go to this slide here real quick and look at an example. So if I have a document like this, so A, foo, B is an array 1, 2, 3, and I did $unwind : on B here, I would get about 3 different documents, one for each different value occurring in the array B. So if we go back to this, here what I want to do is I want to try to figure out the total population across all documents in C data by year. So if you remember back to our C data documents, how each of them had an array called data with 3 entries, one for each year. So by calling unwind, I'll flatten those out, and the output of unwind would actually be 3 documents for every 1 document in the C data collection. So I'd have, what, 156 documents there. And then I'll group those by the year. So here I'm using my underscore ID to group. I'm saying $data.year. So that's going into the subdocument within the data key to find the year. So that same syntax that you use to the dot syntax to get values for embedded documents within the query language of MongoDB, that carries completely over to the aggregation framework. And similarly, I'll use $sum to add up all the total populations. And then finally, I'll do a sort on total population 1. And the $sort operator, that works just like the sort method from the query language. And here I'm sorting 1, so that means it's going to be getting bigger, ascending order, and you can see here the output of something like that. So another kind of closer look at that by unwind on the census key here, kind of breaking down the key elements. I have an input document like this. I'm going to get 3 different output documents for that. For New Jersey, I happen to only have census for 1990 and 2000. I'm just getting 2 output documents over that. All right, I'm going to there's one question that came in from Andy about being able to branch or split the pipeline during later stages. No, there's not really a way to do that. You probably, to do that, you could, there is a way, and I have this later in the slide deck, that you can actually dump the output of an aggregation to another collection. So you could probably have one aggregation that outputs to a collection and then have 2 different aggregations that operate over that collection to do kind of a splitting thing. Okay, so there's a question, do we have an operator like wind in contrast with $unwind? Yes, there is a wind, which does basically just the opposite. It'll take, you group on something and then you can find those same keys and build an array in the output documents. So yes, that is there. Okay, I'm going to move on through the slides now, I think. Oh, I didn't talk about that one. This is just a little bit of an extension of using unwind here, doing a match before to just look at the states in the South. Otherwise that's basically the same as the previous example. Dollar match. This one is probably the simplest. This is using the same syntax as the query language when you do finds. So this one should be pretty straightforward. I think I'll go through that. And now this is actually a bit more complicated, as you can see. And I apologize, the spacing on the slide got a little off here, so it's a little bit trickier to read. But let's talk this through. Now, if we want to start to look at the population change, so the delta here meaning the change by state from 1990 to 2010, this is one way to do it. And actually, something I forgot to mention a little earlier is when you're giving these kinds of problems, like, hey, find the population delta between these years, there's probably multiple different ways to solve this problem within using all the tools available to you with the aggregation framework. There are probably some ways that are more efficient than other ways. Nonetheless, there's usually more than one way to put these together. So just sort of keep that in mind if you're wondering, like, is this the only way to do it? Okay, so in this case, we can unwind, then we can sort by the data year. That's going to put, so remember, the data array had 3 entries for each year. Sorting by data year would put, all the ones for 1990 first, and then 2000, and then 2010. Then it groups by name, and then it builds 2 keys called pop 1990 and pop 2010 using the first and last operators. And so these work because this is going to say, give me the first value for that and then the last value for that. As it groups over all the documents with the same name, the first document that hits the group, the total pop in the data key will go in there, and then the last one that hits that group will go in there. And now $project is a way to transform the documents. What I'm doing here is project, the value of project is kind of similar to group in that you give it a template of the documents that you want to come out of that. And so here I'm saying ID :0, that says I don't want to project the _ID key that comes out of my $group stage. Instead, I want a key called name whose value is the _ID from the incoming group. And then I want a key called delta, where I'm going to use this subtract operator to subtract these two, to subtract pop 1990 from pop 2010, and then pop 1990:1, the alignment's off here, and pop 2010:1. Those are saying I want those keys in my output. And so this is the kind of output that you'll get from something like that. $project is actually really powerful to do data transformations. So you might have a consumer that is really interested in your data, but they need the documents to look different. They can't handle the names of your keys and things like that. $project is a way to transform those documents. All right, so there's 3 other operators that are actually exactly the same as what you're used to when you're writing regular find queries. Sort, limit, and skip are exactly the same. There is a way to, in one of the options that we'll get to later, there's a way, because by default everything will happen in memory, but if you have really large sorts, you could use up all that memory. So you can say allow disk use :true to allow you to sort larger data sets. First and last, I talked about dollar project. I basically talked about all this. I'm skipping ahead because we're going to run out of time here. Just again, the syntax for project, a 0 and a 1, those stand for true or false. This says don't give me the underscore ID. That says give me this field. Otherwise, you can use the same syntax like dollar underscore ID to refer to the incoming documents. So this is just walking through the example I've already walked through. So if you wanted to answer a question about using some geographical data, so we want to count people or compare the population sizes between these three years within people living within 500 kilometers of Memphis. You use this geo-near operator. And here, this is going to assume your data, if you're familiar with the geospatial indexes with MongoDB, your data has to follow the GeoJSON format, which I'm not going to get into during this talk. But here's just an example here, where here I'm saying the max distance is 500,000 meters. That would be 500 kilometers. And near this point here is the coordinates of Memphis, and spherical to use the spherical calculations. And then there are our old friends unwind, group, and sort to kind of massage this data. Running something like this gives you an output like that, and you can see here the states where we counted things were those states, right there bordering Tennessee and the Memphis area. So it's geo-near. We've only got about 10 minutes left. I'm going to skip ahead a little. Here I mentioned this. If you wanted to save the outputs of an aggregation to another collection, you can use $out and then just specify the name of the collection. So that's a pretty nice feature. One note on that is every time you run the aggregation with the $out, it's going to overwrite that target collection that you want to write to. So you need to be careful of that, and if you're using that to design your strategies, to take that into account. Okay, so back to that original question. We were looking for the U.S. division with the fastest growing population density. We only want to include states with more than 1 million people and divisions larger than 100,000 square miles. And here is the final answer to that, which you can see. We've gone from, a very basic group to now here's an aggregation that has, 1, 2, 3, 4, 5, 6, 7, 8 different steps. And you can see the pattern here of doing the match first. So I'm going over that C data collection, but I really only want to match on states that have that big enough population, because that's one of the characteristics of the question I'm trying to solve. And then there's a couple different groupings to massage the data that we've looked at each of the pieces of that, and then another filtering on the total area, and so forth. And the output of that is something like this, and it looks like the answer to our question is that the South Atlantic Division had the fastest growing population density. All right. I'm going to check the questions here real quick. Okay, I'm going to hold off on the questions right now. So here's a couple of the options. I believe I mentioned most of these already. One thing to note is that the return of calling aggregate is itself a cursor. So if you're familiar with how find returns a cursor, aggregate returns a cursor as well. So you can iterate over that. you have the ability to specify different settings on the cursor, like the batch size. This is the allow disk use option to be able to sort larger things, storing intermediate results on disk. And then if you did want to see the explain, you can say explain : true. Again, following all good MongoDB APIs, the options is always an optional last argument to the method. So it's one document containing all these different options. All right, so 3.2. Let's jump into some things there. So there's a new operator called $sample where you specify a size. And this will do a kind of a random sampling over a given collection. It uses some different strategies depending on your storage engine, but if anybody has gotten a chance to download and use our new Compass product, if you fire that up and point it at one of your collections, you'll see you get some sort of sampling of the data, and that in fact does use this $sample if it's connecting to a MongoDB that has is a version 3.2. It has other strategies to connect to your older versions, but this is very useful. For example, if you want to just browse your data, if you're in charge of doing unit tests, or you want to just grab random documents and validate things, I think this would be a really powerful feature for all you testers out there. So check that out. $lookup is one of the other new popular features in MongoDB 3.2. I'm going to go through an example, so I'm not going to go in detail with this. Is just the basic syntax of it. There's a couple things to know about $lookup. Is in the output of $lookup, you're going to get a new field that contains an array of documents that match what you're joining on, and we'll look at an example of that to make it a little more clear. And then the collection that you're joining on at this point can't be sharded. So I'm not going to talk about the details there, but if you are in a situation where you shard your data and you're considering $lookup, you just need to keep that in the back of your head that there are some restrictions there. And you may or may not be able to use $lookup in those cases. So the example here I want to look at is some kind of hypothetical sensor data. So I have a collection called data that has a bunch of values and then a key called key, and then another collection called keys that match up the sort of internal ID 0 to the name of a sensor. East meter, central meter, and hi-fi monitor. And so if I was interested to average up the values from these sensors, but I didn't want to output a 1 for the sensor. I wanted to actually go into this keys collection and look up the name of the given sensor. I can use the $lookup and some other aggregation operators to do something like that. So I'll talk through this example quickly here. So here's a $lookup, and I'm saying I want to go into the keys collection. I want to take the local field K, which is going to be the K on the input here, and I want to map that to the _ID field in the keys collection. So jump back here. So I want to match the 1 to the 1 over here. And then I want to unwind on name because I'm going to return those back as a name value. And if we unwind that because that's going to come back as an array. And I want to hold on a second here. I'm going to, I know we're running short on time, but this is actually pretty important. So I'm going to try to pull up an example here. So really quickly here, let's. Okay, so hopefully you can see my screen. I've got that same aggregation here just in an editor, and I just wanted to show you quickly what happens. All I'm doing down here in the editor is I'm just commenting out all the other stages in the aggregation, because I wanted you to see if I just go over the raw data. So this is my raw data collection. If I just run this script and I just do the $lookup, let's take a look at the output that I get. So for each input, for each input documented data, just running lookup, I'm going to get back a key called name, because that's what I specified for as, but I'm going to get an array of all the documents in the key collection that match it, because there could definitely be more than one. It just so happens in my example that I used _ID to match, so in this case, there would only ever be one, but that's not the case in general when you're doing lookups into another table. So you're always going to get back an array, which is why you pretty much always, maybe not every single time, but almost always, you're going to want to do a $unwind right after you do your $lookup. So so you pretty much always want to do a $unwind. That's basically what I wanted to say with that. And then if you add back in all the other stuff that actually calculates the average and does the grouping, you get an output like that. So let me go back to the trying to unshare my screen here. Okay, so we should be back to here. Okay, I think I'm going to skip this since we're okay. So here's a question. We're getting to the end. I just have a couple of things I want to say, but the question Ken asks is, does $lookup really rely on indexes? Absolutely, it will. And since I'm short on time, I'm going to have to skip over the details of this. But I had an example here to use $lookup to do actually like a self join, like if you're maybe interested in like kind of graph problems like finding friends of friends or paths or things like that. Here's an example of using $lookup to do a self join. And actually, I have a slide that shows why indexes matter. So if I run this, and again, the slides will be available so you can look at the details of that. But here's an example of running that aggregation to find friends of friends without indexes, taking 48 milliseconds. So here I just am grabbing output from the MongoDB log. I did db.set profiling level 0, -1 to make the slow milliseconds threshold -1, so everything will go to the log. 48 milliseconds without indexes. I add an index on friends and name, and I get down to 2 milliseconds. So big difference, and actually within these, there's a lot of other statements in the log, but without the indexes, you see, tons of collection scans, and with the indexes, you see IX scan. So indexes definitely look, definitely matter. Quickly here, tons of other operators to do different mathematical things in 3.2, as well as some more array operators. All this stuff is online in our wonderful MongoDB documentation, as I'm sure most of you are aware. And so I'll just wrap up, and I'll get to the questions. Can you do analytics? Absolutely, and really complicated ones. The one thing you want to think about when you're building your aggregations, though, is even though we had very complicated ones, with 10 or more stages, you just want to concentrate on each little stage. And that little trick I did by commenting it out of stage can really help you debug things, because you can just remember that the output of one stage is the input to another. So if you're not getting the results that you expect, then please just comment out things and try to diagnose where you're going wrong. Okay, so I'll take a look at some questions now, and then also I want to just thank everyone for attending. If you have to drop off, if you have a hard stop, but we'll stay on and do some questions. And have fun using the aggregation framework. And then finally, there will be a survey available, and we really value your feedback. So please, if you have a moment, take a second to fill that out. And I will look at some questions now. Okay, so there's a question from Justin. Sharded means you just have a size limit on your collection, right? No, by sharded I mean you are actually running a sharded cluster, so you have multiple different MongoDBs that are housing a given collection's data is spread across. So it's the way you scale MongoDB horizontally, and so that's what I mean. Not a size limit per se, but an actual sharded collection. Okay. There's a question here about if you use GridFS, can you use the aggregation framework? I'd probably need a little bit more clarity in what you're trying to do. I mean, at the end of the day, GridFS is storing documents in a collection, so I don't see any reason you couldn't use the aggregation framework for things, but I'd probably need a little bit more answer on that one. Sorry about that. There's a question about, David asked, is it possible to group things to an array? I'm not precisely sure what you're meaning there. You can, the value for _ID on a $group can itself be a document so that you could actually group on multiple keys. So a good example of that is, let's say you had a data set of like zip codes, and they had a key for city and a key for state, and you wanted to count up how many zip codes were in each city. Then you could do something like $group _ID : curly bracket, S state : $state, city : $city, and that would make a unique group for each unique city state : city pair. So that's a way to group on multiple keys. If you want to output an array, then you can use the add to set, and the push operators. So I hope that helps with that one. So here's Scott asks, during the webinar, could you mention how Mongo Compass fits in the aggregation framework? Yeah, I mean, it does use the $sample feature to do that sampling of your data. So, I mean, that's the simplest way I know that it fits into that. Okay, data become available with the slide deck. Yeah, so probably what I can do, I think there's different means that they post the slide deck, but some of this stuff is already up on a GitHub site, so I'll add a link to that in the slide deck, and then I can post some stuff up there with some of the examples and things so that everybody can grab it from there. Okay, no, Sunil asked about multiple fields for _ID and group. Yes, I guess I answered that, so absolutely. Sujit asked, how does the aggregation framework compare with Hadoop MapReduce? Well, that's a kind of a large question. I will say that you may be familiar with MongoDB having its own, map and reduce kinds of features. And the aggregation framework was really built to be much, much better than those. If you look out there, if you Google around for these kinds of things, there's a few blogs out there that they take the same problem and they try to do it with JavaScript MapReduce in MongoDB, MapReduce in MongoDB, and then use the aggregation framework. And the aggregation framework performs like many orders of magnitude better. So if you're doing MapReduce now, this isn't particularly talking about Hadoop because that's an entirely different technology. But if you're doing aggregation or MapReduce kinds of things now with your applications, you should probably rethink those and use the aggregation framework. All right, so I'll just do a couple more questions. Shank asks about, suppose there are millions of records. Will aggregate load all the records first? Will it eat all the memory RAM? So you do need to be careful there. It's going to process things in stages, right? So yes, just like a big query that did a full collection scan of a large data set could thrash your working set, aggregations can do the same thing. So you need to make sure you have the right indexes in there. And then if you're doing lots of sorting and things like that, you probably want to use that allow disk use true option as well. Now, actually you will get an error if you try to do a sort that can't be done if it runs out of memory. So you'll be able to detect that probably at development time. Okay, so let's. Okay, so I'll take one more question here from Justin. Can you use a $lookup operator more than once in an aggregation query? Yes, you can, definitely. And that's kind of the beauty of the whole design with the pipeline, is all the steps are independent of another, right? The input at the beginning is a collection, and then the output and the input down the pipeline is just a set of documents. So they don't really know anything about what happened before or what happened later in general. Okay, I think that's probably good for the questions, and we're about 10 minutes over. So I want to thank everybody again for joining. And again, we'll get all the samples and the slides out to everyone and on our website. And appreciate your time, and have a good rest of your day or evening. Thank you.